Ever wondered how a tiny atom can unleash tremendous energy, enough to power entire cities or potentially devastate them? That's the intrigue of nuclear energy, a force both fascinating and formidable. It's the energy that fuels our sun, and it's the same energy harnessed by humanity to generate electricity. But this incredible power doesn't come without its risks. Nuclear energy is a double-edged sword. On one hand, it offers a near-limitless source of clean, efficient power. On the other, it carries the potential for catastrophic disasters, such as the incidents of Chernobyl and Fukushima. The secret behind this potent energy lies in the heart of an atom, where processes known as nuclear fission and fusion take place. These processes, despite their intricacies, are the key to unlocking the tremendous power of the atom. So, what's the secret behind these powerful processes? How do they work? Prepare to dive into the fascinating world of nuclear reactions. Imagine a tiny particle, a neutron, speeding towards a large, unstable atom. What happens next is nothing short of a dance of the atoms. Picture this: a neutron, smaller than the eye can see, on a collision course with a much larger, unstable atom. This atom could be something like uranium or plutonium, elements notorious for their instability. As the neutron approaches, it doesn't just bump into the atom. No, it's absorbed by it, becoming a part of it. This might seem like an inconsequential event, but it's anything but. This absorption causes the atom to become even more unstable than it was before. It's like the atom has become too full, too laden with particles. So, what does it do? It splits. It cleaves into two smaller atoms, a process we call nuclear fission. But the atom split is far from a quiet event. It's like a miniature explosion on an atomic level. As the atom splits, it releases a massive amount of energy. This energy, in the form of heat and radiation, is what powers nuclear reactors and atomic bombs. And it doesn't stop there. The atom split also releases additional neutrons, and these neutrons are now free to collide with other unstable atoms, causing them to split and release even more energy. This creates a chain reaction, a domino effect that can lead to an even more powerful release of energy. Nuclear fission is not just a physical phenomenon, it's a dance of the atoms, a spectacle of nature that demonstrates the immense power locked within the smallest particles of the universe. It's a dance that can light up cities, power spacecraft, and yes, even bring about destruction. And just like that, an atom splits, energy releases, and the world as we know it changes. But the dance of the atoms doesn't stop there. Now imagine two light atoms speeding towards each other, colliding and forming a heavier atom. This is the power of the stars, the process of nuclear fusion. Nuclear fusion is all about unity. It's about light atoms coming together to create something more. Picture two hydrogen atoms, the lightest of all, racing towards each other at astronomical speeds. When they collide, under the right extreme conditions, they don't just bounce off each other like billiard balls. Instead, they merge, they fuse, to form a new heavier atom, helium. But this is no ordinary transformation. This fusion doesn't just result in a helium atom, it also releases an incredible amount of energy, even more than the process of nuclear fission we discussed earlier. This energy is so vast, so powerful, that it lights up our universe. Yes, you heard it right. Nuclear fusion is the process that powers the sun and the stars. It's the force that keeps these celestial bodies burning bright, the cosmic dance of atoms that illuminates the night sky. Imagine, every time you bask in the warmth of the sun, or gaze up at the constellations, you're experiencing the results of countless nuclear fusion reactions. It's a process that's happening millions of miles away in the heart of our sun, and yet its effects touch us every single day. But the power of nuclear fusion isn't just confined to the cosmos. Scientists and engineers are striving to harness this incredible energy here on Earth. They're creating conditions extreme enough for fusion to occur, in the hope of creating a new, clean, and virtually limitless source of energy. Yes, nuclear fusion could be the answer to our energy needs, a solution that's as powerful as the stars themselves. It's a testament to the incredible potential of atomic energy, and to the ingenuity of human beings who dare to harness it. So, from the heart of a star to the core of a nuclear reactor, the dance of the atoms continues, creating and releasing energy in ways that are truly mind-boggling. So, we've danced with the atoms, witnessed their splitting and their merging. But what's the difference between fission and fusion again? Let's take a moment to revisit our atomic tango. In one corner, we have nuclear fission, the heavyweight champion of the atomic world. This is where a large atom, typically uranium or plutonium, is split into two or more smaller atoms. It's a bit like a heavyweight boxer losing weight to drop a division. This process takes place in environments like nuclear reactors and atomic bombs, where neutrons are used as tiny subatomic bullets to break apart the nucleus of the atom. The split releases a tremendous amount of energy, alongside more neutrons that can go on to split other atoms, creating a chain reaction. It's a self-sustaining cycle, like a perpetual motion machine, but with the power to light up cities or unleash devastation. On the other side of the ring, we have nuclear fusion, the agile featherweight of atomic reactions. This process involves the joining, or fusion, of two light atoms, usually hydrogen, to form a heavier atom, typically helium. It's sort of like two featherweight boxers bulking up to move up a weight class. This fusion happens under extreme conditions like the core of the sun or other stars, where temperatures reach millions of degrees and pressure is immense. When these atoms merge, they release energy even more potent than that of fission. It's the power source that fuels the stars and, one day, could provide us with an almost limitless supply of clean energy. So in essence, fission is the process of breaking down, and fusion is the process of building up. They are two sides of the same atomic coin, each with their unique characteristics and energy outputs. And there you have it, the dance of the atoms decoded. From splitting to merging, these nuclear reactions hold the key to some of the most powerful forces in the universe.